John. So as housing providers, your service is to provide safe, secure, and affordable housing to vulnerable members of your community. To do this, your organization relies on the people that work so hard to make this happen, but also on buildings or assets. Maintaining building performance is key to providing this service. Interruptions can be costly and have consequences to your organization's finances, occupant comfort, and even the environment. In order to maintain this level of service, a plan or a process must be put in place. Now, in life, there are very few things that perform better the more you use them. Maybe a good baseball glove, or pair of jeans possibly, but building systems do not usually follow this trend. As usage increases, performance will start to decrease. Without having a strategy to mitigate this, costs will increase, energy will be wasted, and occupant comfort will decrease. At BC Nonprofit Housing Association, our asset management team helps affordable housing providers integrate energy management into their asset management practices. This helps reduce operating costs, reduces greenhouse gases produced, and it increases tenant comfort. And of course, it helps keep affordable housing affordable. So first, let's talk about asset management. Asset management works to minimize the cost of owning capital assets while ensuring required service levels are met. Asset management can be a simple process, or it can be more complex depending on the organization, but it always connects four key elements: people, information, assets, and finances. Asset management connects the expertise and activities of people with the information about a building's assets and finances. It connects all of these so that informed decisions can be made that will support your organization for years to come. So, asset management will minimize costs and helps to reduce service interruptions. Well, why do we need to worry about energy management then? Energy management helps organizations lower their energy use, which in turn reduces operating costs, greenhouse gas emissions, and passes these benefits on to the occupants. Just as with asset management, energy management practices connect people with information, and this allows them to make informed decisions that will help their assets reduce energy consumption. Today, we'll look at three pathways that connect energy management and asset management practices. We'll try to see how we can connect people with information about their organization's assets and finances, but we'll also connect those to energy consumption. In doing so, we'll find pathways leading to a sustainable delivery of the services that are so critical to your operations. For the first pathway, we'll look at how we can support our organizations while reducing energy consumption and provide a solid foundation for the other pathways. Asset inventories and maintenance plans are items that support organizations of all sizes and are part of an asset management plan. An asset inventory is the first step to understanding what you have in your building. If recorded with enough detail, it will provide serial numbers, installation dates, and other information that you only realize how valuable it is until you need it. At BC Nonprofit, we've worked with small societies with one building run by volunteers that have simple asset inventories created in Word documents. Like Maureen here, a volunteer who maintains 20 units of affordable housing in beautiful Rosslyn, BC. Her asset inventory contains detailed information of systems and assets in each unit and helps other volunteers like her daughter and granddaughter share this information and maintain consistency. Other nonprofit organizations have had their asset inventories developed through professional services. BC Housing has commissioned a software tool, Asset Planner, to capture building data collected through building condition assessments. This is a web-based program owned by Amoresco that is a repository of building data, which can be shared between BC Housing, BC Nonprofit, and the building owner. At BC Nonprofit, Asset Planner is used as the host for our capital planning template and is accessible to nonprofit housing providers. Another example of how this data can support your organization and its asset management planning. So I'll give you an example of how an asset inventory recently helped a society I'm working with. A retrofit project was wrapping up and they had a good chunk of budget left. How often does that happen? Well, the funders suggested they use the remaining budget on another project if they had the need. After coming to BC Nonprofit Housing Association with this information, we were able to access their asset inventory through Asset Planner and can see that the building's hot water tanks were a priority item in need of replacement. In a matter of minutes, we were able to begin building the business case showing a need. We connected people with information about assets, leading to informed decisions to be made about finances and energy use. A secondary source of funding has been secured, and we're looking to move this project forward with a low carbon option to further reduce greenhouse gases emitted. So we have information about our building systems. Oh, let's go back a slide. We have information about our building systems. We need to pick a maintenance program. A maintenance program is a set of related activities with a long-term plan that keeps systems running smoothly and prevents costly downtime. But having a maintenance program connected to energy management can further help reduce maintenance costs and improve energy performance. And on an organizational level, creating policies that link maintenance with energy management can ensure all aspects of your property operate in an efficient, consistent, and safe manner. Unfortunately, a lot of nonprofits haven't connected information about their buildings and energy use and operate within the emergency maintenance program. As complaints start to roll in, an investigation begins, and the system is either repaired or replaced. Sound familiar? The problem efficiency-wise is that the system may already be wasting energy leading up to the breakdown. And then on top of this, if a replacement is necessary, energy efficient equipment usually is not considered. The planning really starts in the middle at routine maintenance. And as we move into preventative maintenance, we really start to connect the specific needs of the building system with a plan. Again, this comes with help of our asset inventory, so we can get specific manufacturer recommendations on the maintenance. Let's pause now and highlight a few of these low-cost preventative maintenance items that could lead to 5 to 10% energy savings right now. So we'll start with something that everyone has at home, in the office. This stuff is everywhere. I'm talking about dust. Wait, how does dust affect the efficiency in our buildings? Well, for baseboard heaters, dust actually makes it harder for the heat to transfer from the baseboard fins into the surrounding room. Now more energy will be required, more greenhouse gases produced just to provide that same amount of heat to the space, just from not dusting. So next, you look at your asset inventory and it shows building controls, and you think, well, what maintenance can we do here? Simply checking to see if the controls are working is a great start. During my career as a Red Seal electrician, a common thing I'd see would be motion sensors set to bypass, or outside lights that would be on all day. Ensuring these controls are operational and staff are trained to use them are the first steps to access the savings they're designed to provide. Heating set points are an important maintenance item to check. Set them as low as possible while still providing appropriate space and water heating level for tenants. Communicating with tenants is key for this to get ahead of those complaints. And a final item you may not think about when it comes to maintenance is insulation. I mean, how do you maintain that? Well, I've been in countless attics where the insulation has been walked on, compressed, or pushed to the side, decreasing its ability to prevent heat transfer or insulate. In this case, the heating system again has to run for longer, more energy consumed because insulation levels have not been maintained. Having an asset management plan in place is necessary to support optimal building performance and maintaining the value of your assets. So what resources are there to help? At BC Nonprofit, we have online courses that can help building operators gain experience in creating asset inventories, maintenance plans, and help with their capital planning. The Canadian Mortgage and Housing Corporation, Natural Resources Canada, and FCM have guides and tools that integrate energy efficiency into your property management procedures. Our next pathway to unlocking energy savings takes us to building checkups. So over time, buildings become less efficient and they consume more energy just to provide that same old service. But what if we could integrate building checkups into our asset management process that would detect opportunities to improve building performance? Asset and energy management are both data-driven practices, so let's start by collecting more information. The first place to start is with a level 1 or walk-through energy audit. Just like the name states, an energy audit will walk through the building, looking at mechanical, lighting, and building envelope systems, and they'll speak to building staff. A report will be generated, providing an overview of building systems and highlighting areas where energy may be saved, even providing low to no cost solutions. Energy conserving measures, or ECMs, will be identified, and systems will be noted that require further investigation. At BC Nonprofit Housing Association, the free walkthrough energy audits we provide to affordable housing providers are one of the first ways we approach connecting energy and asset management within their organization. And through FCM's Sustainable Affordable Housing Initiative, regional energy coaches are available throughout Canada to help provide this service to nonprofit housing providers and co-ops. These walkthrough audits are a great way to set up the next kind of building checkup, level 2 audits. A level 2 audit is an engineered energy study that provides more detail about the energy conserving measures, their costs, and expected savings. This detailed study provides the information needed to make informed decisions about building upgrades and can ensure energy efficiency is prioritized. Funding options are available to help with this step. Here in BC, utilities have programs to help fund energy studies, and the Sustainable Affordable Housing Initiative's planning and study grants are resources that can help make these engineering studies happen. Energy audits can also show the need for the final type of building checkup, recommissioning. Recommissioning is an optimization process that benefits large buildings with complicated systems or high-performance buildings of all sizes. In fact, buildings that have integrated building management systems may perform poorly if recommissioning is not accounted for. So the goals of recommissioning align with those we talked about today, ensuring building needs of occupants are met while reducing energy consumption. Recommissioning looks at how building systems are operated and maintained, and then optimizes the design, performance, and the system's integration with the rest of the building. It assesses the staff's ability to operate and maintain these items, and it can be shown to reduce energy use by 5 to even 30% annually. So what does recommissioning look like in action? Here's a story of how small actions lead to big savings through recommissioning. Our story takes us to Sunset Towers in Vancouver, BC. The towers are heated by a central mechanical plant supplying hot water to radiators, rooftop ventilation units, and heat exchangers for domestic hot water. BC Nonprofit Housing Association partnered with BC Housing to leverage funding through BC Hydro, our electrical utility, and FortisBC, our natural gas provider. They began by completing a FortisBC custom energy study, or level 2 audit, to help identify energy conserving measures. Impact Engineering was brought on to perform this study, and what they found in their first site visit was interesting. The existing systems already had high efficiency equipment. After looking into the design, it was clear the complexity did not make for efficient operation. It was also clear that the building automation system was failing to perform its function. This was causing maintenance personnel to make manual adjustments to the system. The combination of these factors was preventing the mechanical equipment from reaching its high efficiency potential. A recommissioning of the system was in order. The first step was to physically separate the hot water heating and space heating piping. Now certain boilers would be used for hot water and others for space heating. This eliminated a complex control valve and allowed the boilers to match the heating demand required. Recommissioning was working to redesign the system rather than just install expensive, high efficiency equipment. In addition to this, a new DDC control system was installed, which allowed for the boilers and ventilation systems to be adjusted based on the outdoor temperatures. Air volume could be adjusted seasonally as well. These controls also helped ensure that domestic hot water was stored at the ideal temperature range. So, on to the numbers. In the first year post-retrofit, Sunset Towers saved more than 4,000 gigajoules of natural gas, accounting for over 200 tons of carbon emissions. This equated to a 25% reduction in annual natural gas use and a payback of under 2 years. This is a great example of how thoughtful planning and design can lead to small actions that unlock big energy savings. Let's get those buildings working smarter, not harder. So it's great to recommission when possible, but what about when things just need to be replaced? How can we ensure our asset management process is connected to energy management? Energy efficient retrofits will provide the last pathway to improving building energy performance. So it would be easy just to look at an older system and say, swap that out with the like for like model. It worked before, so that's all you need, right? Well, that approach doesn't attempt to connect people with information about their assets and finances, and especially energy use. Here's what's possible when energy efficient design and equipment selection is prioritized, and what happens when it's not. Our second case study involves replacing a building's boilers, but not because they are old and breaking down. In fact, They were less than 10 years old. Let's look at why it's important to have systems designed with energy efficiency prioritized from the onset. Our story takes us to Dunwood Place in New Westminster, BC, 193 units of affordable housing. BC nonprofit followed its usual playbook for this one, beginning with a walkthrough energy audit, setting up a utility-funded engineering study. This study identified the need to replace the boilers and hot water heating systems and recommission the ventilation system. So why, if the boilers were less than 10 years old, would it be a good idea to replace them? Well, they were actually too big for the building, which was causing them to cycle on and off frequently, especially in low heating conditions. The domestic hot water was being heated through instantaneous coils, requiring very hot water, and additional boiler runtime now because of the cycling. The recommendation from the engineers was to replace the boilers with smaller condensing models and replace the instantaneous hot water coils with the storage tank system. This would prevent the boiler from cycling on and off and allow for staging of the boilers, leading to higher efficiency. This upgrade led to a 30% reduction in energy use by the system. This example highlights the need for not only selecting energy efficient equipment, but having it properly sized and staged for the most efficient design possible. This will maximize energy savings as opposed to just replacing the unit with a like-for-like model. But the energy savings did not end there. The ventilation system was identified as a potential target. It was overventilating the space, consuming too much energy. Energy was just being wasted. The existing air makeup unit was relatively new and it could be modified. Airflow was just reduced by almost 3 times. Air balancing was performed at the supply grills, and the supply air temperature was also lowered, leading to even more energy savings. In total, the project resulted in natural gas savings of approximately 2,500 gigajoules per year, equating to 135 tons of CO2 emissions. Subsequent maintenance costs were reduced, and the total energy savings were approximately $18,000 per year. This project was a great example, and we were able to stack utility and BC housing funding to cover the cost for the entire project. 3 pathways leading you towards energy savings that are just waiting to be found. Thanks for your time today. It's been a pleasure to talk to you about connecting people with information about their assets, but also their energy consumption. Thank you.